Welcome to LNP Renewable System Integrators. Today we are going to see some of the basics of PLC hardwares and its IO components. So while entering into the topic, let us try to ask some of the questions to ourselves. See, what are the input and output sections of the PLC and what are the features of this PLC? And let's try to know the examples of an analog input and output devices. Okay, how these digital input and output devices are getting powered. Okay, how if we have a remote IOs, okay, how we will connect with the local controllers. Okay, and let us try to see some of the examples of discrete input and output modules. How the basic addressing is done in the ladder logic. Okay, and if you have a temperature measuring device, how it is get connected with the analog module, and what are the field devices. Okay, how the field devices are getting connected with the fixed PLC module, and how PLC works with a little example. Okay. Okay, first, so if you try to know about the input and output sections of the PLC, see, this is a power supply module. Okay, and this is the input and output module racks slots. Okay, and if you get depth into the PLC, okay, it will have a power supply and it will have a central processing unit CPU, and it will have a memory, program memory, and a data memory. Okay, and for the if you are having any HMI screens, then we need to communicate. So for that, we should have a communication interface with the CPU module. Okay, for that one only this provision is provided. And if you get depth, if you want to connect a local controller with the PLC module, then we need a communication interface. For that one, we are using this module. Apart from it, we should have a digital input and output device connecting modules, as well as analog input and output device connecting slots. So based on our requirement, we need to choose the PLC based on that. Okay, so this is an example. What are the features, okay, in it? So if you see, this is an input module. These are the sensing devices. See here, so many devices are there. Okay, push button is there. Okay, NONC contact buttons are there. And if you try to know about the output module, it is getting connected with the load devices, that is light, motor, okay, speakers. Okay, all these are getting connected with the output modules. And see here, between this input and output module, the most important component which powers everything is that a power supply. Okay, even for the CPU to work, it need a power supply. So the power supply is the heart of the system, and most importantly, the brain of the system is the central processing unit, and it should have a memory. Okay, the memory is going to define the how many IOs you can able to connect with the CPU. So memory also we can classify into two. One is program memory and the data memory. Okay, and see, let's try to have a little example about how the analog input and output devices are connected. See here, if you have a PLC, okay, which has a processor, that is central processing unit. So let's try to consider this as a processor. Okay, now we are connecting we are having a analog input module. Okay, so we have a level transmitter which produces a 4 to 20 milliamps output. So that output we need to connect with the analog input module. Now we have a requirement that we need to show the level transmitter, that is how much level it reached. We need to show with the help of an indicators. So it means it is an analog output also. So what we are going to do, we are taking the level transmitter input from here. Okay, with the help of this analog input module, with the help of the processor, we are processing it. That is nothing but we are going to make a logic inside it, and with the help of the analog output module, we are going to indicate it, what is the level. That's it. Okay, see here, this is another example. Okay, how the analog input and output modules are getting connected with the PLC. See here, we have a level transmitter. It shows the level of the water. Okay, so say for example, the level transmitter output is 2 to 10 volt or 4 to 20 milliamps output. So with the help of this analog input module, we are taking the output of this level sensor. Okay, we are with the help of this PLC, with the help of this logic, we are processing it, and we made a logic that if the level fills the tank, then we need to close the valve. So valve is an analog device which operates with 4 to 20 milliamps output. So in order to create that 4 to 20 milliamps output, we need the analog output module. So we are taking a level sensor as an analog input. We are processing with the PLC. With the programming, we are making a logic that if the tank level fills, okay, we need to make the valve close. So we are making a logic inside it, and with the help of this analog output, we are providing an output command, okay, control to this valve. Okay, in some certain cases we can take the feedback from the valve also. What is it? obeyed our command or not, so how much it is open, those things also we can do. Okay, so this is a simple example. And most probably we all know that in the slot type, okay, we will have a power supply unit, and we have a slot to add the input and the output modules. So from the power supply, the power will get distributed to this input and the output modules. Okay, and as we saw earlier, okay, so it doesn't mean that all the field devices should be present in the same place. It might be at the different place. Say for example, motor will be in the one place, okay, through the belt it might be, and the hopper system or the other field devices or sensing devices might be in the other places. Okay, so we cannot locate the panel, okay, that is our controller panel, in all the places. Okay, it is a, so in order to be a cost effective, we can do one thing. We can have a remote IO modules. See here, this is a local input and output controller. See here, we have a power supply, we have a processor, we have input and output devices, and most importantly, we have a communication interfacing facility. See here, this start stop button is an digital input, so we are connecting with the input devices, and we need to control a motor, so the motor is getting connected here. See here in the other location, we don't have much devices. That is, we have a on off control switch and we have a sensor. So both there is an output, there is an input, but it is located in the remote location. So for that one, no, there is no need for the processor separately. So what we are going to do, we are just providing a power supply, and we are providing an input and output module, and in order to communicate with the main CPU, we are having a communication interface. With the help of this communication interface, we are communicating with this local controller with the remote controller. This is how a local controller is getting connected with the remote IO panel. See here, the only difference is that the main controller will have a processor and the remote IO module will not have any processor. But for that one, power supply is essential for the input and output modules to work. Okay, and let us try to have some of the examples of the PLC input and output module. See, we have a digital input. See here, this push button is an example of the digital input. Okay, and we have a selector switch, this is an example, and we have a proximity switches, this is as another example, and we have a limit switch also, this is also another example of the digital input. And if you go for a digital output, okay, indicator indicating lights, okay, is an example of the digital output. Okay, signaling column, this is also a light. And then if you want to operate any relay, that is a best example of the digital output module. And we have a motor starter as well. Okay, this is another one more example of the digital output module. Okay, output device. So how basic addressing is done, we are going to see now. See here, let us try to have an example. Okay, we have a water tank. Okay, in that one we are filling a water. Okay, and most importantly, we are let us consider it as a boiler, so it will have some temperature, and for sure the water will be coming with some sort of pressure. So it is getting encapsulated inside a tank, so that there will be some pressure. So we have a pressure sensor switch, and most importantly, it's like a mixing unit, so that we will have a motor. So what are the devices we are having? We are having a manual push button, uh, terminal temperature switch, pressure sensor switch, and we have a motor. So if we try to segregate them as input and output devices, so manual push button will be an input device, and pressure sensor switch will be an input device, and temperature switch will be an input device, but motor will be an output device. See here, so this is how the logic is made. So we have a pressure switch, temperature switch, and the manual pusher. See the difference. This is rung defines a single thing, that if the pressure is switch is on and if the temperature switch is on, then motor can start working. Okay, or with the help of the manual push button, if you try to press that one, the motor can operate directly. So this is the logic we had made. See here how we had done the addressing. See here, we had provided the pressure switch the first priority, so the addressing is I/1, and for the temperature sensor switch we are providing the I/2, so two inputs, and the third input for the manual push button we are giving it as I3. This is how basic addressing being is done. Input 1, input 2, and input 3, and we have only one output device, that is a motor, so we are addressing it as a O/1. See here, whatever the input device we are connecting, the addressing starts with the I. Okay, the nomenclature, the naming scheme, programming scheme differs from different sort of controllers, because we have variety of controllers like Siemens, Allen Bradley, um, ABB, Mitsubishi, Omaran, G Fanuc, like that. So many brands are there, and Delta. So they have their own way of addressing methods. But whatever PLC it will be, if it's a normal input addressing will start with I or X. Okay, and if output means all the addressing will be starts with O, or we can go for Y. So this is how the address is going to be, and based on the variety of input and output, maybe the nomenclature might differ, but everything will start with this is how the basic addressing scheme has been started. Okay, so so we are checking all the inputs. Okay, in order to execute the program, we are going to make a program. So this is an example of the program, and we have the output. Okay, so now let us try to consider another example how a temperature sensor is connected with the analog module. See here, so we have a thermocouple. So if we'll have a positive negative line, so we're connecting it with a IN2 plus and 2 minus. Okay, and here default it has a ground, but we are not making any special grounding. Okay, but if you see here with another example, a temperature sensor, we are doing a grounding at the tip. Okay, so as we saw earlier, so we saw some of the input devices and output devices, right? So how it will get connected with the fixed type PLC, because we saw the modular type. Now we are trying to see how it will get connected with the PLC. See here, the program is already there. Okay, so the pressure switch, temperature switch, and the push buttons are all the input devices, so which is getting connected on the input side. Okay, for the controller to work, we have a line neutral connections, and second, on the output side, we have only the motor. Okay, so as we told earlier, okay, uh, this example, if you see, we have a manual push button, pressure sensor switch, temperature switch, and a motor. So if you try to segregate them as an input and the output devices, okay, based on the discrete and analog signal, this manual push button is a digital input, and this temperature switch is a digital input, and the pressure sensor switch is a digital input, and this motor is a digital output. Okay, say for example, instead of this temperature switch, if you have a temperature sensor which is producing an output of 4 to 20 milliamps, then it will comes under the category of analog input module. Okay, analog input device. So it will get connected with the analog module. So we will add a analog module. If instead of this pressure switch, okay, this is a digital input. If you go for a pressure transmitter which produce an output of 4 to 20 milliamps, in that place, okay, an analog input module will come. So based on the field devices, okay, our controllers modules are getting decided. Okay, so thank you so much. So to learn more, feel free to contact us. Okay, to know more and learn more, please subscribe and press the bell icon. Okay, so to learn more and to do the project with us, feel free to contact us. Okay, we are providing design, installation, testing, and commissioning support for industrial automation, home automation, and the building automation as well. Okay, and for the solar also, we are providing design, installation, testing, and commissioning, and consultancy support. Feel free to contact us. Thank you so much.